Hi everyone, today I want to talk about multiple linear regressions. So firstly, I want to give you some explanation about what is the multiple linear regression. This is a statistical method for understanding the relationship between one prediction or dependent variable and two or more explanatory variance independent variables. Here is some example of this. So you can predict the house price using the area, number of the bedroom, and the age of the house. In the education here, you can predict the student score based on the sleeping hours, attendance, or workloads. In the marketing, you can predict the campaign return on investment based on the budget, channels, and the period. So now I want to break down the mutable linear regression formula. Firstly, you can see the model, and you can see the Y here, right? So this is the target or dependent variable. The B0 here is the intercept or the starting value of the prediction. B1, B2, and Bn is the coefficients. So this is the part I will explain later in Excel. X1, X2, and Xn is the independent variables or explanatory variable. Last one is the error terms. The error terms is the difference between the actual value and the predicted value in the model. So now I will check the assumptions. So first one, the linearity. So the linearity shows the relationship between the independent variables and the dependent variable should be linear or approximately linear. The next is independent. So you can see this one has trend, right? And has some increase trend, and this one is wavy trends. So if the arrows are related to each other, it means the model did not catch some pattern in the data. So it is missing something important and not fully explaining what is going on. So the most satisfactory in thing is here. This one is independent. You can see that this one, right? Okay. Next one is the homoscedasticity. So this one ensures that the model estimate are reliable. Sorry. So the variance of the error must be constant. If not, the model work better in some area in like this and work very badly in some area. So it leads to the unreliable prediction because the predicted value are not treated nicely. Just last one is the normalities. So the errors need to be normally distributed. So the statistical test p-value, t-set, or confidence intervals used in the regression are valid and reliable. However, if it had the skew distribution like below like this, you can see this one, right? So the test for the coefficients might be give a wrong p-value, lead to a wrong conclusion for the model, and that is very dangerous. Next one, I want to talk about some evaluation about R-square. So firstly, R-square is a value between 0 and 1. The more close to the 1, this means that it had a wave model. However, if the value close to the 0, it means that the model is very bad. So now, we talk about some R-square. But first, I have to remind you that because we have so many tools to calculate the model or the R-square, so like Python, Excel, or Power BI, so sometimes we don't need to calculate it by our hand. However, I just show you a little bit about this for you to understand more about this formula. So SSR is the sum of the square regression, also known as the variation explained by the model. LST is the total variation in the data, known as the sum of the squared total. And this is the formula for each of those. This is the first one, and this is the second one. So now, let's go to the root mean square error. So the root mean square error is commonly used metrics to measure the difference between the predicted value and the actual value in the regression model. So the smaller value of the root mean square error means you are close to the actual value, and this is a good thing because your data is very close to the reality. So now applications are put in Excel.
So I have the data here in Excel, and now I will show you how to do a regression in Excel. Firstly, we have to come to the data analysis, this one here. We scroll down to the regression section right there. You can see that, right? So when you see it, click on there, click OK. Yep, and it will appear this one. So what this table means, first one, input wide range, which means that is the predicted value, sorry. So it's the predicted value of my data is the product itself, and I already do it for you. Yeah, you can see this one. And now I want to input the X range. So what this means? So if the input range here is the explanatory variables or independent variables. So this means that all the data from here to here and down all of this here. Yep. Okay. Now we have two of these, the predicted variables and the independent variables or explained variables. So now I want to click the label because I take the non-numeric data. I want to take this one is okay. Check the zeros, zero plus, and line fit plus. This one can help us to make the to visualize our assumption in the next few seconds and next few minutes. Okay. Okay. Now we click the OK button here, but because I have the regression table, so now I don't need to do it more. Yeah. Now go to the regression. Firstly, this is a summary output. So I will show you how to read it. In the first table, the regression statistics, there are two things we have to confirm, that is the R square and adjusted R square. So for the R square here, that's in 99.99%, so which means that um, the model prediction are extremely close to the actual production sales, and although all the advertising can be explained by the model. The R-square here is say that if only increase if the new variable improve the model, and if R-square adjusted if for the compare two model together, which one is higher, we take that. That's all. Okay. About the ANOVA. So in a ANOVA, you can see the more important thing here is the F statistic and significant F. So this one is a large number, which means so it means that my model explains the data very well, much better than just using the average. The model prediction are very well close to the real value, sorry. And this one, the significant F is less than 0.05, which means that the model is statistically significant. So next one, the more important part table. So now So firstly, I want to show you what is the coefficient is. So first, the coefficient is how much the outcome change when the variable increase by 1, holding orders constant. Standard error. Standard error will show you how precise the estimate is. The smaller, the better, more confident. The t-stat. T-stat is so how many standard error away from the zero of the coefficient is. The bigger, the more confident. And the bigger the more significant, and except for the intercept this one here, and all of the parts is very large, right? Last one, the more important thing in the part, p-value, and I can highlight it for you to more understand about this one. Yep, sorry. This one I like here. Okay, so now p-value. So the p-value is show that it tells the variable is statistically significant or not if the values is less than 0.5. So you can see all the right is 0.00000. So from TV to affiliate marketing, it has a significant, it's statistically significant and has a meaning to the model. And this one, so why this one it has a large p-value? I can explain it one very simply because they did advertising data, right? So this company uses marketing to to marketing their products. So when they don't use the marketing or the marketing don't exist, so this one is not have any meaning for the model. So that's all. So now I want to show you how to read the assumption based on of the table. So firstly, the linearity, we use this table, right? Okay. So now I will go to, because I will copy this one to the linearity sheet, and I will have this one. Uh, to have this one, it's very easy. We just like there, we go to select data and this one. Okay. So I just want to see the the blue one. So let's take this one and this. So this one has the trend line. You go to the trend line here, and you go here, and it has this one, and you display the R square value on the chart, right? Similarly, we can do it in like this in the order, and this assumption can help us understand more about how each independent variable is it has a relationship with the independence. Is strong, is not strong. So and which is the strongest and which is the weakest. So in here we can see the strongest, which means R square is 30%, and the most weakness is R square is 1%, 2%, sorry. So back to the regression, and you can see this one here. So coefficient, right? So this one is very large one, and even is a most smallest one, right? So it's the good one. Okay, next is independent of the residuals. So I said independent of the residual, which means that all the arrows must be independent, which means they don't have any trend, they don't have to related to each other. And when you see six of these, right? You can see all of those are randomly scattered, randomly positioned. So we can show that this all of the variable is satisfactory the assumption too. This one is satisfactory the assumption linearity. This one is satisfactory the assumption for independence of residuals. Thirdly, so how to create this one? First, you can see this one, right? So where I can take that one? You come back to the regression, you remember that I told you how to take the residual. So this one right here. You take two of these, and I highlight it for you. This one is you later for the other thing I will show you later. So first, this one. You have to take this one. Yep. And you copy all of the data to this one. So when you have the data, you can insert, you can choose the recommend chart, and you see, oh, and you see the scatter here, scatter. So what does that mean? Which means that, like I said in the assumption tree, the homoscedasticity, which means that this one, the predicted value will twist fairly, and all the derivation or all the predicted values is fairly. The last one is a normality. Sorry. This one we also satisfies the assumption tree. Yep. And last one is a normality. So where I can take that one? So you can see this one, right? This one. Yep. So turn back to regressions. You take only for this one because in the slide I show you, right? This is the residual of the normality, which means is equal that arrows. So you take this one, right? You have to copy and paste here. You Control A to select all the data. You go to the recommendation, and you can see this is the histogram. So you can see the histogram right there. Even although this is not the perfect bell shape, however, it don't show any two skew to the left or right. So which means that even this one, the model still not affect too much, and the model still choosable, and we can still choose the p-value test. This one we can still choose the p-value step and the p-value for the coefficients. I showed you all the parts of Excel on the definition and all the theory. So I hope you will more understand about this one. Thank you for listening.